Okay, so the next question that we have here is also an interesting question, and there is a couple of things here also to learn. So the question is, show that the path of a moving point, you want to show that the path of a moving point such that its distance from two lines distance from basically 3x minus 2y is equal to 5, and 3x plus 2y is equal to 5. Call this number 1 and call this number 2, such that its distance from these two lines are equal is a straight line. So basically you have a moving point, and you want to show the path of this moving point in such a way that its distance from these two lines are equal. Its distances from these two lines are equal. That path is a straight line. So basically the lines over here are 3x minus 2y is equal to 5 and 3x plus 2y is equal to 5. Now the solution is also here interesting. Well, I did not think of the solution. I just read it and it kind of made sense to me. Not yet, but let's go through the solution together. So you can say that let h comma k be is any point whose distances from the lines 1 and 2 actually distance here means distance over here means perpendicular distance. You need to be careful about that. Whose distances from the lines from basically 1 and 2 are equal. So basically the formula that we had over here, we had basically D is equal to the absolute value of ax1 plus by1 plus c over the square root of a squared plus b squared. That was the perpendicular distance of a point from a line. So then basically I can say that the distance of basically h comma k from 1 I can calculate it as, for example, d1 and write it as, so this line over here, number 1 is basically my a is 3, my b is negative 2, and my c is negative 5, because this 5 has to come to the other side. So I take this as the absolute value of ax1, so that is basically 3 times x1, which is equal to h here, plus b times y1, so that's negative 2 times k, plus c, which is equal to negative 5 over the square root of 3 squared plus 2 squared, which is basically 9 plus 4. And also you can calculate the distance of h comma k h comma k from the second line, or from 2, and that would be basically, for example, d2, which would be basically 3 times, would be the same thing. So 3 times this, the absolute value of 3 times h plus 2 times k minus 5 over basically 9 plus the square root of 9 plus 4. And since these two distances are the same, of course I can say that d1 is equal to d2. That's the assumption that we made. So I can write the absolute value of 3h minus 2k minus 5 over the square root of 9 plus 4 is the same as the absolute value of 3h plus 2k minus 5 plus 2k minus 5 over the absolute value of 9 plus 4. And then you can simplify, cancel these two out. So you have basically this absolute value equation, which is 3h minus 2k minus 5 is equal to the absolute value of 3h plus 2k minus 5. And so you can write this as basically 3h minus 2k minus 5 is equal to the plus or minus 3h plus 2k minus 5. And so you get basically two cases over here. Either 3h minus 2k minus 5 is equal to positive 3h plus 2k minus 5, in which case you would have, you can cancel these two out, and then these two you can cancel out. So you have basically negative 2k minus 2k is equal to 0. So negative 4k is equal to 0. So that means that k is equal to 0. So over here k is equal to 0. And over here your k is equal to 0. And I have no information about h here. I don't understand what it means when h is basically cancelled out together. And then if you write this as, there is one other possibility, that 3h minus 2k minus 5 is equal to negative of this, which is negative 3h negative 2k plus 5. And so then k's will cancel out, and then you will get 3h plus 3h is equal to 5 plus 5. 6h is equal to 10. So that means that h is equal to 10 to 6, which is equal to 5 to 3. H is equal to 5/3. Again, I don't understand really what it means when in this context my k's are cancelled out, and again over here my h's are cancelling out, and in each case I get only one of the variables that I was looking for. But my point is supposed to have both h and k in both the cases, which means that which I don't really understand what it means. Now let's go through the solution and see what happens. So basically, and the same thing happens over here as well. Solving these two relations, we get k is equal to 0 or h is equal to 5/3. Thus the point h comma k satisfies the equations y is equal to 0 and x is equal to 5/3. Right, so basically what that means is that basically So when you have k is equal to 0, that means that the h is, well, for whatever reason, is not there. And since this was the y coordinate of that point, this satisfies the equation y is equal to 0. And if and also in this case, likewise, you have h is equal to 5/3. H is equal to 5/3, which means that, I see, h is equal to 5/3, and that satisfies the equation x is equal to 5/3. And if you pay attention to basically the way that h and k were basically this pair over here. So this was the x coordinate. So this satisfies the equation x is equal to 5/3. And when we say that satisfies the equation x is equal to 5/3, what that means is that, for example, let's say that 5/3 is 1 2/3, for example. So 1 2/3, let's say that it's a line like this, for example, some line like this. If this is, for example, x is equal to 5/3. So it's a vertical line like this. Now on this line, wherever you go, x is equal to 5/3. And y is equal to 0 is basically this line over here. Is the x-axis. This is y is equal to 0. Now on this line, wherever you go, y is equal to 0. That's basically why we say basically these two satisfy these two equations. And of course these two basically are straight lines. These two are straight lines. And these two are basically both straight lines. Hence path of the point equidistant from line and from the lines 1 and 2 is a straight line, meaning that let's actually do the graph of this function and see what we get. So basically the lines that we had were 3x minus 2y is equal to 5, number 1, and basically 3x plus 2y is equal to 5, number 2. So now if I draw this line over here, I will get basically 3x minus 2y is equal to 5. And so that means that negative 2y is equal to negative 3x plus 5. And so 2y is equal to 3x minus 5. And y is equal to 3/2 x minus 5 by 2. So what that means is that we have we have this line over here, which is the 5/2 is basically 2.5. So 1, 2, 3. That there is your y coordinate, and 3/2 is your slope, which means that your slope is 1.5, meaning that from this point you have two, basically let's say 1, 2, for 2 units of horizontal change, you have 3 units of vertical change. So 1 and 2, and then basically 1, and then 1, and so basically 1, you have, so you want to get from here to 3 units of vertical. So you are at negative 2.5, and 3 units of vertical change, you will end up over here. So that means that the point is over here, and that is basically your line. That is your line. So this is number 1. This is number 1. Now number 2 Number 2 is basically 2y is equal to negative 3x plus 5, or y is equal to negative 3/2 x plus 5 divided by 2, which is basically this point over here is your y-intercept, and your slope is negative 3 by 2, meaning that for 2 units of horizontal change you have negative 3 units of vertical change. So you have 1, 2, and 3. You will end up over here. So the other point is over here, and so this is your line. This is your line. Now it's not very neat, but you get the idea. So this is number 2, and so we saw that basically the one of the points was basically one of the points was basically one of the paths was basically the x-axis itself, and I suppose these lines are supposed to intersect exactly on the x-axis. I can show you over here what I mean by that, because otherwise the solution is not right. So if you go to, for example, desmos.com and graph these two functions, let me graph this function. So I write 3x minus 2y, 3x minus 2y is equal to 5, and also 3x plus 2y, 3x plus 2y is equal to 5. As I mentioned, you see that the two lines intersect exactly on the x-axis. I suspected that, because otherwise the solution would have been wrong. And then the solutions that we got over here were y is equal to 0 and x is equal to 5/3. So you have y is equal to 0, y is equal to 0, y is equal to 0, which is basically this line over here, and x is equal to 5/3, which makes sense, because as you go along this line, and these are the two lines that you have, this is the one, this is the either line number 1 or number 2, and this is the other one. And so as you go along this line, you're going to be at all times, you're going to be equidistant from both of these lines. And the same thing happens on the other side of the line as well. And then as you go along this line, you're going to be equidistant from both of these lines, and as you go along in the negative direction, the same thing is going to happen. That's something interesting. Okay. Now the next thing that we have here, there are some miscellaneous exercises on this chapter. There is a lot of them, like 24 of them, but I don't really want to skip any of them. So we will start with these exercises, so I'll see you in the next video.